we're going to go through and talk about Chapter 4, some of the probability considerations that you have. Let's go ahead and get started with this. One of the things that we do talk about a lot of times when we talk about probability is, where do these probabilities come from? Relative frequency. Relative frequency is we go and we do something multiple times and get the calculations. For example, where do insurance companies get the probability of that a 17-year-old will have an accident in a year? They go through and they measure these things. They get a bunch of 17-year-olds, follow them through the year, and find out that 10% have an accident. That becomes a relative frequency, and they take that relative frequency and build it into their calculations for insurance rates. It's based on that type of a calculation. Subjective. And you'll see that I've already written some things down here. This is actually the second time I've done this part of the video, so I'm using some of the notes again. I got about this far. Anyway, subjective. I think that probably one of the best examples of this is going to be in weather predictions. Weather, the news guys on the weather, a lot of times they have 20 different models that they use. So they'll go through, and this model will say this, and this model will say this. I think that in Texas, you just take the prediction for rain and you reverse it. For example, if they say that it's a 90% chance of rain, we'll probably have a 10%. If it's a 10%, we'll probably have a 90% chance of rain. My personal opinion doesn't count for much. But the subjective probability, have you ever wondered why these are always in multiples of 10? The prediction of rain is never 15% or 16% or 86%. It's always 10, 20, 30. It's a subjective thing. They're just giving you the best guess. 1 out of 10 times, 1 out of 5 times that this situation exists. That's what we're going to get. And then we also have another place where probabilities come from. It is the classic, which a lot of times you'll see that as the counting. And so the good example of this would be to go through and to roll a dice. And if it's a fair dice, you're going to get a 1 out of 6 times, a 2, 1 out of 6 times. So you can roll that dice, and then you can see, yeah, I do get out of 100, I got 16 of these, and I got 16 of those, 17 of those, 20 of those, whatever. Flipping a coin, same thing, flipping a fair coin. Those are physical things that can be counted. So that's how that's going to happen. Well, a lot of times in the counting probabilities we're going to go through and let's say that we have some people and we want to know how many different combinations we can get here. So let's say that we have an A, a B, and a C. All right, and we're going to take and see how many different ways we can order those. Well, you can have ABC, BCA, CAB, and we can order them backwards. CBA, ACB, and BAC. So you see that there's 6 different ways that we can order those 3 different combinations. Well, how can you get a formula to calculate that? Well, you have 3 choices for the first letter, and after you choose that first one, then you have 2 choices. And then for the last one, after you've chosen 2, you have 1. So that's going to give you 6 different ways that you can order these. 1, 2, 3, 4, 5, 6. Okay, let's go through and we'll add another level of complexity to it. Let's say that we have these 3 things, and we want to be able to go through and order them in, we just want to pick out 2 of the letters to order them. So that means that we could have AB, AC, BC, CA, CB, BA. So we can go through and with just 2 letters, we can get another 6 different combinations there. That's if the order is important. If the order is not important, then these 2 are the same, and these 2 are the same, and these 2 are the same. And so we have a calculation that we can use, that we use when the order is important. And if the order is important, then we use what is called a permutation. Okay? And that's going to be P for permutation. N of R is going to be N factorial over N minus R factorial. So let's see how that applies here. So the permutation of 3 letters taken 2 at a time, that's what the R is going to be 3 factorial over 3 minus 2 factorial. And so that's going to be 3 factorial over 1 factorial, which is going to be equal to 6, which is what we predicted would be the answer there. Okay? And so there's another situation that exists, and that's going to be called the combination. And that's going to be used where over here order was important, over here order is not important. Okay? And so that's going to be the combination of NR is going to be N factorial over R factorial N minus R factorial. So that would, to calculate that, that's going to be 3 factorial over 2 factorial, 1 factorial for this particular situation where N was 3 and R was 2. So that's going to be 3 factorial, or 3 times 2 times 1, let's do it that way, over 2 times 1 from this part of the equation times 1. So these cancel, and that gives us an answer of 3, which is what we had already said. There's 1, 2, 3 if order is not important, and 1, 2, 3, 4, 5, 6 if they are important. Just a quick review of that. I'm going to stop this particular video at this point, and then we'll pick up with some other comments with the second video.